Hello? Hello? Say hello to Coco Bananas. There she is. This is my weasel. This is my ferret. Oh, such a good weasel. She just woke up, so she might not be too active. Look what I have for you guys. Look what I have for you calculus students. I made another maximization problem. Yay! Ah! Oh, there's a weasel. All right. All right, let's see what we got. The curve is a simple thing. It's just a parabola pointing up with the vertex at x equals 3. So you can see the parabola in the picture. And look where I stuck a rectangle. I want the vertex to be on that parabola, but the opposite corner, stick that at the origin. What do you think? What do you think, Weeze? What do you think? Well, she knows what to do. She's not stupid. She's a good weasel. But she wants to get down. There you go. All right. So let's see what we got. The area is going to be this distance, which let's just keep calling it W. It's a good name. Because notice you're measuring from the origin. So this distance will be the same as its coordinate. That's good. That's good. And then the height of it is just from W up to the curve. Well, that's W minus 3 squared. Now you might say, well, but wait a second. W is going to be less than 3. So you're going to get like 2 or 1 or 1.5. And then 1.5 minus 3 is negative, but notice it gets squared. So the y coordinate being positive makes sense. It's cool. It's cool. So this is my area. I'm going to do the derivative by product rule because I can. So it's the derivative of w, which is just 1, times the other factor unchanged, plus the derivative of w minus 3 quantity squared. So the 2 comes down. This factor unchanged. So I put the 2 way out front. Pro move. Pro move. Some of you are confused by this, but the 2 comes down and multiplies. Stick it out front. Who cares? So you got a 2. This is this w because it's unchanged. And I was doing the derivative of this. The 2 comes down, inside unchanged to the 1 less power times the derivative of the inside, but the derivative of the inside is 1. So you don't have to write down that 1. Anyway, now check it out. Don't multiply anything out. Factor out w minus 3 because each term, see this plus sign, 2 terms, each term has a w minus 3. So it's w minus 3 times w minus 3. But there's nothing else happening to this w minus 3, so I didn't even wrap it up with parentheses. Then that's this plus sign, and then this w minus 3 got factored out, 2w. There we go. So this becomes 3w minus 3. Whoa! So check it out. W equals 3 is one of the places that gives us 0. But if W equals 3, we have no area. The rectangle would be flat. So that's a min. This guy, 3W minus 3, if we have 3W minus 3 equals 0, that's 3W equals 3. That's W equals 1. Oh, W equals 1 looks really good in this picture. It's a possibility. W equals 1 makes sense. So we still have to get the max area. The max area is supposed to be then 1 times 1 minus 3 squared. Oh, so I can see how this 1 is is a good choice because you do have a factor out front of that same number. But over here it's 1 minus 3. So it's actually good if you choose a number here that's far enough away from 3 to leave a nice beefy piece to get squared. So this area comes out to be 1 times 2 squared. Well, that's 4. That's max area. I'd like to show you something. We didn't do this yet. Let me show you something that you can actually do that's useful. I would like to see if this is actually the max. So let's try. Let's just try. How about, we try. This is just us playing around. We try a w equals, instead of 1, let's try 1.1. Let's try 1.1. Because this is a nice size, area of 4. We're just working with a little corner of space here. Like up here, this goes all the way up to 9. So, it's bigger than it looks, this little area where the rectangle is. But it's not huge. So is this 4 as big as it gets? Well, let's try, if I put in 1.1 times 1.1 minus 3 squared. So that's my area if the w equals 1.1. Well, luckily I brought a calculator. I'm not going to do that by hand. 1.1 is fancy numbers. So I've got 1.1 times the quantity, 1.1 minus 3, quantity squared. I hit enter. Whoa, can you see it? Can you see it? Can you see it? Oh, come on, you stupid camera. Come on. I'm trying to get that number visible. It's 3.97. I can't make it appear. God, I'm such an idiot. 3.97. 3.97, which is less than 4. And being less than 4 makes me happy. So this is a new little trick here that I'm laying on you guys. You can actually sort of check your maximization answers without having to go in the back. Well, this is a good thing to have, when you go to do something that's graded work or like a test or a quiz. You can now check a number near the number that gives you the max. Check something near it, and you should come up with something less than what your max was, which is very convincing. That I think you're right. If you put in 1.1 and you got 4.2, then you made a mistake, because 4 was supposed to be the max, and you found a number that gave you more than 4. So you must have goofed. But when you get a number like this, you put in something that's 1.1, a little bit close to 1. You get something close to 4 but less. That's how it goes. That's how you check. Okay, you guys, that's it for the day. You got to see Cocoa Bananas. See you at school.